This is Knowledge Engineering with Semantic Web Technologies, lecture number 6, Knowledge Engineering. This is the second part of linked data engineering, and I want to give you a short tour through the linked data cloud. In the last part of the lecture, we have talked about the linked data principles and the generation of linked data. And we said, following these principles, a huge cloud, a huge network of interconnected data sets has been developed over the last years, and this is often referred to as the so-called linked data cloud, of which you see here a very nice representation. Besides the black and white representation, we have here a colored representation, and here it's interesting because here the single sectors within this ellipse have different colors, and these sum up, of course, data sets which belong to a specific category. And I will give you brief statistics about these data sets, about these categories, followed by what connects these data sets, so which ontologies are used simply for connecting these data sets amongst each other. If you are interested in the statistical data we are talking about, you simply have to follow that link that is presented here on the left side down on the slide. Okay, let's start. In the upper left corner, there are data sets together which are related to government data. So in the past years, lots of governments have opened up their data and they have published their data, and several of them also in the form of linked open data to be accessible via linked data technologies, via semantic web technologies. So these are 183 data sets overall, and among the top 10 data sets with the highest in degree within this cloud, there is also one of the government data sets. It's the reference.data.gov.uk. So this means the UK government data, for example, is here a rather prominent data set because it is among the top 10 data sets with the highest in degree, which means which receives the most references in there. Overall, in these government datasets, 48 proprietary vocabularies are used, and about 21% of all of the data is fully dereferenceable. What does that mean? Just remember, dereferenceability, it means when I have an URI, I want to look up the data for this URI. So I try simply to put this URI in my browser, or I have an application which tries to access via HTTP and then accesses the RDF representation. Then I want to have, of course, information about that URI. And only for 21%, of course, of these URIs, they are fully dereferenceable. This is only a small fraction, and this comes because, of course, it's complex, and of course it's cost intensive to provide infrastructure for dereferenceability of your data. Of course, for some government data it's much more cheaper simply to publish a data set in which, of course, then the URIs are, but they do not necessarily have to be dereferenceable. So this is the case, and I hope this is a growing number here. So 21% of these data is fully dereferenceable. Okay, let's have a look at the next one. There we have media-related data sets. So the blue one are media-related data sets, and among them also, of course, some data like the BBC program data or stuff like that is there. So these are 22 data sets. Among them, 22 proprietary vocabularies are used, and unfortunately, fully dereferenceable are none of these data. But partially referenceable are about 9%. So 9% of the URIs that are presented here are really dereferenceable. That's really a rather small number, and of course we all hope that this will grow in the future. Let's continue. So in the upper corner here in orange, you see user-generated content. So user-generated content, this is lots of interesting data, which of course comes somehow from portals which enable services where users provide their own data somehow. So there are 48 data sets among them, and of course the most prominent with the highest out degree there among the top 10 highest out degree data sets is the semanticweb.org data set, which of course contains many links throughout the linked data cloud. Therefore it's there, of course, as one of the highest out degree data sets. It uses 30 proprietary vocabularies, and 30% of the data here is fully dereferenceable. About 10% is partially dereferenceable. Here in the next section we have data or datasets about linguistics, and unfortunately these datasets have not been part up to now of the statistical evaluation. Therefore I can't give you any reference for that. But you see this is a rather small number of datasets among there. Then we have here again a big section with the screen data. This is bibliographic data, data about publications of any kind. So there's much of library data in there, for example. Authority files are in there. And there are 96 datasets overall, and there are some of the datasets with the highest in degree as well as datasets with the highest out degree over there. So for example, the datasemanticweb.org is one of the datasets which has the 10 highest in degrees, and the bibsonomy.org, which is a bookmarking tool, so you can manage your bookmarks with bibsonomy.org, and besides your bookmarks, of course, also your citations and bibliographic references. This has one of the top 10 highest out degrees. There are 58 proprietary vocabularies used, and 21% of them are fully dereferenceable, while 7% are partly dereferenceable. So bibliographic data might also be interesting, and maybe we will later also have a look at that. So then you have a large section with data which comes from life sciences. So life sciences has a long tradition and also a strong tradition with artificial intelligence, for example. Therefore, it was rather easy to translate legacy data sets that were already represented with the help of ontologies and make them also available here in the linked data cloud. So these are 83 data sets. 35% of them are described with proprietary. So there are 35 proprietary vocabularies used, sorry for that, and 28% are fully dereferenceable. So this is, considering the other numbers, already a huge number of dereferenceable URIs, and 6% are partially dereferenceable. So the next section, these are the cross-domain datasets. So to the cross, or part of the cross-domain datasets, is also the DBpedia dataset, which is at the hub, so at the right center of the linked data cloud. Overall, it's 41 datasets which have this cross-domain knowledge. And of course, among the top 10 datasets with the highest in degree, there is, of course, as a reference, dbpedia.org, but also w3.org, or this is also an interesting site, lexvo.org. I have no idea what it's about, but these three are among the top 10 sites with the highest in degree throughout the entire linked data cloud. So here we have 55 proprietary vocabularies used, 27% were fully dereferenceable, 11% partially dereferenceable. And of course, for example, for DBpedia, you know that all of the URIs are fully dereferenceable, for example. We are almost done. So look at the next part. So here in blue, this is social networking data. So these are many, many data sets, 520 data sets overall. And there are also some of them among the top 10 with the highest in degree and out degree. So for the in degree, we have a site which is called quitter.se or status.net. I also don't know them. And for the out degree, we have derry.org. This is a research institute, and we have heart.org. And there, of course, simply because of the sheer number of datasets, there is also a high number of proprietary vocabularies, 128, 16% fully dereferenceable, and 6% at least partially dereferenceable. And now we have almost finished our tour. So the last section here, the yellow dots, they represent geographical data. So the most prominent about them is geonames.org. And these are 21 data sets, and among the top 10 with the highest in degree definitely is geonames.org. We have 24 proprietary vocabularies used here. 21% are fully dereferenceable, and 4% are partially dereferenceable. So this is the entire linked open data cloud. The question now is, look at all these small arcs which are between the bubbles you see here. The question is, what kind of properties are they? Are these also or only same as properties, or what kind of properties are referenced here? So what holds the linked data cloud together are ontologies. And here you see a small picture of the most important ontologies which are used for interconnecting these data sets. So here we have several. We have FOAF, we have WordNet, we have GeoNames, we have SHOC, we have AMBL and SCOS and many more. You might never heard of them. Therefore, I want to introduce a few of them to you because we will sooner or later see them when we do then linked data discovery, knowledge discovery and all the stuff. So, most prominent, most important, we already know. It's vocabulary from the OWL reference data. So OWL same as connects, of course, identical individuals, and OWL equivalent class connects equivalent classes. So this is really used rather often within the linked data cloud, and within the statistics you can also find out for how many percentage of the links they are here OWL same as or OWL equivalent class links. So they are very important. But sometimes, of course, individuals are not necessarily identical, but somehow related in another way to each other. Somehow classes are not really identical because some of them might be broader or narrower if you compare them with each other. Therefore, you need additional vocabulary. And here the most prominent vocabulary that you can use is the so-called SCOS vocabulary. SCOS is the abbreviation for Simple Knowledge Organization System. It's based on RDF and RDFS, and it's usually really used to link vocabularies together somehow, to make mappings between vocabularies and ontologies. Let's have a look at the vocabulary you have here. You can denote classes also with SCOS class. This does not necessarily have to be an RDF class or an OWL class. SCOS class is an own concept for class to combine SCOS classes with SCOS concepts. Nevertheless, you also can combine other kind of classes with the SCOS properties you see here. And you have here, for example, narrower and broader, which then, for example, it's like in a taxonomic or hierarchical structure. If you go and specialize something, then you define a narrower concept. But this is not a real subsumption relation. It's only a term that is narrower than the other term you compare it with. And the same is with broader. This again creates a hierarchy, but it's not a true subsumption. It's a hierarchy. It defines a somehow broader concept. And then you have SCOS related. So if this is not a hierarchical kind of relation, it might be some other relation, then you say it's SCOS related. And concerning the matches between vocabularies, you have here SCOS exact match, SCOS narrow match, SCOS broad match, and SCOS related match, which means an exact match, of course, then both identities or both entities that you relate with each other are exactly the same. If they are very, very close, but not exactly the same, but nevertheless really, really close, then you have a narrow match. If they are a little bit more on the side or not really exactly each other, then it's a broad match. And then you also have the related match, which is the weakest form of match. So you see here, you have different qualities how to match entities within the web of data. And of course, this makes sense because they all carry some kind of meaning and semantics, and that you can use, of course, then later on when you are working with that knowledge. So this is the SCOS vocabulary. What is also an interesting ontology within this linked data structure is the AMBL ontology. AMBL is also an acronym, and it stands for Upper Mapping and Binding Exchange Layer. So this is a subset of a much larger ontology, the OpenPsych ontology, and it's all encoded in RDF triples based on SCOS and OWL2. So overall, this ontology contains 28,000 concepts that are expressed as SCOS concepts, and there are 46,000 mappings into DBpedia, into GeoNames, and into other data sets. And mostly these kind of mappings are expressed with OWL equivalent class or RDFS subclass and other things. And overall, there are more than 2 million Wikipedia pages linked into AMBL, which denote identical concepts here. So this is an interesting alternative ontology, alternative classification system that can be used to classify then also DBpedia entities, besides the DBpedia ontology and the DBpedia classes that are already available. Okay, this was only a small glimpse into the most important vocabularies. Feel free to look up all the others, make yourself a grand tour through linked data, get acquainted with the concepts, with the entities you find there, because then in the next lectures we will try to do knowledge extraction, knowledge discovery, knowledge mining. But before we can do that, we have first to look at the principles of linked data programming. And for that, we will make a short program together and you will see the basic principles, how I can use standard APIs and all the stuff we have talked about within an application.